This is lesson unit 3, section 6.3. We're going to factor, and these are special factors. Difference, of course, that means subtraction, and then squares. Square trinomials, difference, that's subtract, and cubes, and sum of cubes. A difference of squares. In our factoring chart, these are going to be numbers that come in this middle section, 12 times 12, 11 times 11, 10 times 10, and so on. The difference is that one of them is going to be positive and the other one is going to be negative. So in every case, the middle term is going to be 0. It's going to drop out, and so we'll just end up with a first term squared, a subtract sign, a second term squared. And when we factor it, we take the square root of the first, the square root of the second, and we add them, and we subtract them. So if we had x squared minus 25, that would factor into x minus 5, x plus 5. 49 minus 25 would be 7 minus 5, 7 plus 5. 49 minus 25 is 24. 7 minus 5 is 2. 7 plus 5 is 12. 2 times 12 is 24. That's just kind of interesting. Y squared minus 64 is y plus 8, y minus 8, and so on. Okay, so here we've got 100 right here. 100, 0, p minus 10, p plus 10. 10 and 10. Factor a 2 out of this one, we're left with x squared minus 9, which is 3 and 3. X plus 3, x minus 3, and don't forget the 2 out front. 3a minus 4b, 3a plus 4b. Now we could actually use our factoring chart to figure this one out. Multiply these two together is 144. What two numbers multiplied equal 144 are 0 apart. So we would say plus 12ab minus 12ab, and then we could factor by grouping. But it's easier to just remember this simple rule. So this is a difference. So we would have m plus 3 minus 7z, m plus 3 plus 7z, y squared minus 4, y squared plus 4. Now, if you wrote that as the answer, you would get this one wrong. And the reason is that this first part here is still factorable. This is factorable into y minus 2, y plus 2. So the whole thing is y plus 2, y minus 2, y squared plus 4. Remember, it only works if this middle sign is a negative. So this would be 2m minus 5 n, 2m plus 5n. Factor 9 out of this second one, we're left with x squared minus 81. So it's 9 times x minus 9, x plus 9. A plus b minus 5, a plus b plus 5 are the two factors here. V to the fourth plus 1. V squared plus 1. V squared minus 1, but remember v squared minus 1 is factorable. And so we would get v minus 1, v plus 1, and don't forget the v squared plus 1 at the beginning. So that's how you do a difference of squares. When we get to perfect square trinomials, the first term is going to be squared, the last term is going to be squared, and the middle term is twice those two. Now this also is found on our chart, 49, 1, and 14. 49 and 14 is right there. So we could split this up into minus 7 and minus 7z, and then we would be able to factor it. But it's easy enough to just take 7z minus 1 squared. Now why minus? Because this sign is minus. And if we multiply that out, we get 49z squared minus 7z minus 7 more z plus 1, which is 49z squared minus 14z plus 1. Okay, square root of the first term plus, because this is a plus sign, square root of the second term squared. And now let's check our work. 3 times 8 is 24. Twice is 48. Now, this one, if you notice here, it looks a little bit different until we would group this so that this is x minus 1 squared. Okay, do you see how we factored this into this? Now we have minus y squared. Now we have a difference of squares. So we have x minus 1 minus y and x minus 1 plus y are our two terms. A plus 6 squared, 4x plus 7y squared. Oops, this is supposed to be minus. I didn't see the minus sign there. This last one, this is a square. This is y minus 8 squared minus z squared. So it's y minus 8 minus z times y minus 8 plus z. Remember, this part here is inside parentheses twice. How about a difference of cubes? Now, the thing about a difference of cubes is that if we multiply this out, x minus y times x squared plus xy plus y squared, this times this is negative y cubed. This times this is negative xy squared. This times this is negative x squared y. This times this is plus xy squared. This times this is plus x squared y. This times this is x cubed. Notice this term and this term cancel out, and you're left with x cubed minus y cubed. The clue is when you see a difference of cubes, take the cube root of the first one, write it first, put the negative sign in, take the cube root of the second one, and then square this, write it at the beginning, square this, write it at the end, and multiply these two together and write it in the middle. You must, absolutely must, have exactly one negative sign in your answer. Okay, so let's see what we've got here for the first one. Okay, when we factor it, we get x. That's the cube root of the first term. Put in the negative sign. 10 is the cube root of the second term. Square this first term, x squared. Square this term, 100. Write it at the end. Take this times this is 10x. And we have exactly one negative sign, and that negative sign is right here. Okay? Follow the same procedure every single time. Cube root of the first term, copy the sign, cube root of the second term, square the first term, square the last term, multiply these two together, and we have exactly one plus sign, or minus sign, excuse me. Cube root of the first term, copy the sign, cube root of the second term, square the first term, square the last term, multiply these two together, and we have exactly one negative sign. Cube root of the first term, copy the sign, cube root of the second term, square the first term, multiply them together, 1t, square the last term, you have exactly one plus sign. Cube root of the first term, copy the sign, cube root of the second term, square the first term, square the last term, multiply these two together, and you have exactly one plus sign. If it's a sum of cubes, you factor it the exact same way. The only difference is where the negative sign is. The sign of the second term of a sum or difference is always the same as the original polynomial. This always matches this. You always have exactly one negative sign. Cube root of the first term, cube root of the second term, copy the sign. Square the first term, square the last term, multiply these two together, and you have exactly one negative sign, and the negative sign is right there. Cube root of the first term, copy the sign, cube root of the second term, square the first term, square the last term, multiply these two together, exactly one negative sign. Factor out a 2, cube root of the first term, copy the sign, cube root of the second term, put the 2 out front, square the first term, square the last term, multiply these two together, you always have exactly one negative sign. Cube root of the first term, copy the sign, cube root of the second term, square the first term, square the last term, multiply these two together, and you have exactly one negative sign. So this is going to be negative, which I guess makes this negative and this positive. Okay, square this part is a squared minus 8a plus 16 minus ab plus 4b plus b squared. A minus 4 plus b. There you go. Okay. Cube root of the first term, copy the sign, cube root of the second term. Square the first term, square the last term. First term times the last term, exactly one negative sign. Cube root of the first, cube root of 81. Oh, we can take a 3 out of everything first. 3 parentheses, 27a to the 6th plus b to the 3rd. Okay, so cube root of the first term, cube root of this, or copy the sign, cube root of the second term, square the first term, Square the last term. Exactly one negative sign. Multiply this out. Last one. I'm going to change colors. Cube root of the first term. Copy the sign. Cube root of the second term. Square the first term. Square the last term. Multiply this out. Xy minus 3y. And multiply this as x squared minus 6x plus 9 minus xy plus 3y plus y squared x minus 3 plus y. Okay, so here they are. Remember that you can only, with squares, you can only have a difference. You can have a perfect squared trinomial, and you can have a sum or difference of cubes.